Writing a token contract is the easy part. Making it safe enough for regulated issuance is harder. In this module, we'll bring together permissioned logic, trusted libraries, testing, audits, governance, and upgradability into a production-ready smart contract mindset. So far, we've moved from issuance architecture through platform choices into token models, standards, and modular contracts. Now we'll connect those pieces in a practical contract review, using a security mindset before we move into settlement architecture. In regulated issuance, a smart contract is more than code. It acts as an automated control gate. If that gate fails, tokens may move incorrectly, assets may freeze, and compliance evidence may break. Think of the demo contract as a regulated token in miniature. Issuers can mint, administrators can manage roles, and compliance operators control eligibility. Before any transfer succeeds, the contract checks both the sender and the recipient against the permission registry. If either side is not approved, the transfer is blocked. The contract can also burn tokens, pause activity in an emergency, and emit events so off-chain systems can monitor, reconcile, and preserve audit evidence. A strong implementation begins with proven OpenZeppelin contracts, rather than rebuilding token mechanics from scratch. Choose the closest standard, such as ERC20, ERC721, or an upgradable version, then add reusable safeguards like AccessControl, Pausable, and role management. Keep custom code narrow, eligibility rules, transfer restrictions, and issuance logic. Finally, pin and document library versions so builds are reproducible, and auditors can verify exactly what code was used. Permission token contracts also need role design that reflects real governance. The admin role should control upgrades and role assignment, but rarely handle daily operations. Minting, burning, pausing, and compliance checks should be separated, ideally behind multi-sig approvals or defined workflows. The danger is a single wallet that can issue tokens, freeze activity, change permissions, and upgrade logic on its own. Clear boundaries reduce insider risk, simplify audits, and make operational responsibility visible, both on-chain and inside the organization. At the center of a permission token is the transfer hook. Before balances change, it checks whether the sender and recipient are eligible. If either check fails, the transaction reverts, ideally with a clear custom error. Eligibility can come from local contract storage or from an external registry tied to KYC, allow lists, jurisdiction, or investor status. The key is consistency. Every transfer path must enforce the same deterministic rules. Emergency controls should work as a safety valve, not a shortcut. A good response starts with detection, then assessment. Is this a platform incident, a legal order, a sanctions update, or a compromised wallet? Next comes approval by the proper restricted roles. Only then should the system pause transfers or freeze specific accounts. Just as important, every action must emit events, feed monitoring, and support audit review, so teams can resume normal operation with confidence. Upgradability is a trade-off, not a default. Immutable contracts give users certainty, but defects can be permanent. Proxy patterns keep state stable while routing calls to replaceable logic, which enables fixes. That power needs strong governance, multi-sig approval, time locks, and clear notification. The dangerous detail is storage layout. A bad upgrade can corrupt balances or roles. Define the upgrade policy before deployment, including what may change and who can authorize it. A strong testing strategy proves more than the code runs. It proves the token behaves correctly under real operating conditions. Use Hardhat or Foundry to automate repeatable tests. Cover both approved actions and rejected actions, especially unauthorized role use. Then test the full asset lifecycle: minting, transfers, restrictions, pausing, unpausing, burning, and role changes. Finally, measure coverage across statements, branches, functions, and permission checks. In regulated tokens, missed edge cases can become compliance failures. Static analysis gives the team an automated first pass before human review. Slither is fast and practical for catching common solidity issues, from unused variables to reentrancy indicators. Mithril goes deeper, using symbolic execution to explore paths that may expose access control or storage mistakes. The point is not to accept every alert blindly. Triage each finding by severity, exploitability, and business impact, then fail the CI/CD pipeline when a risky change should not move forward. Design review is the threat modeling checkpoint before the formal audit. Start with power. Who can mint, burn, pause, upgrade, or change eligibility rules? Then examine token behavior, reentrancy, rounding assumptions, denial of service paths, and whether events fully support investigation. For regulated assets, the critical question is bypass resistance. Can compliance be avoided through hooks, secondary transfers, or upgrades? Finally, challenge every dependency, including registries, oracles, identity providers, and custody operations, because external failure can become contract failure. Audit readiness starts before auditors arrive. The goal is to package the contract so an independent reviewer can understand what it is supposed to do, how it is secured, and how claims can be verified. That means design documents, architecture, roles, assumptions, limitations, test results, static analysis, and unresolved risks. It also means operational evidence, deployment steps, upgrade policy, and runbooks. A strong evidence package reduces back and forth and helps auditors focus on real issues. Use the demo as evidence for an architecture decision, not just as a coding exercise. First, confirm that the contract still matches the token model and lifecycle requirements. Then review OpenZeppelin dependencies, custom logic, tests, and static analysis as one audit package. Next, challenge the control model. Admins, upgrades, pauses, emergency actions, and monitoring. The outcome should be clear. Go, conditional go with mitigations, or blocked until residual risks are resolved. The core lesson is that token issuance is more than working code. Strong architecture combines reviewed components, disciplined testing, static analysis, and human security judgment. Audit readiness adds documentation, privilege controls, deployment discipline, and upgrade policy. Next, we connect these assets to settlement, stablecoins, DBP, reserves, and treasury controls.